Hello, my dear students. Today we will discuss some of the important points you should be remember if you are a civil engineer. This video will be helpful for your interviews if you are going for any site engineer interview or as a design engineer interview. We will start one by one. What is the minimum cover that should be provided for the structural members? Okay, what do you mean by structural member? Structural members are those members which will take the loads from the structure and finally it will transfer to the footing and footing to soil. Okay, what are the structural members here? Say footing. What is the minimum cover should be provided for the footing? That will be 50 mm, for column 40 mm, for beam 25 mm. Okay, you can put 25 to 30 mm, for shear wall 25 mm, for slab 20 mm, and for staircase that is 15 mm. This much of cover should be provided for the different structural member. Okay, one thing you should know, why the cover should be provided for the structural member. Why the cover should be provided? Okay, because in order to resist the corrosion, okay, in order to avoid the corrosion, and second, in order to avoid from the fire. Okay, and next one is here, if you see in this question, in this answer, the footing is 50 mm and column is 40, beam is 25. Why the footing cover is given 50 mm? The reason behind that one is footing is directly in contact with the soil. That's why usually the water directly enter into the foundation. It may, due to that water, the steel may be corroded. If steel corroded means the structure will be collapse. Okay, that's why uh, cover for the footing is more. And one more thing, here you should know what do you mean by clear cover and what do you mean by effective cover. Okay, first we will clear that one. What do you mean by clear cover and what do you mean by effective cover? Okay, in the diagram here it is explained. Okay, what do you mean by clear cover means outermost surface of the concrete to the nearest main reinforcement. This is called clear cover. This one is called clear cover. And what do you mean by effective cover? Effective cover means center of the reinforcement, that is main reinforcement, to the exterior surface of the concrete. That is called effective cover. Okay, this is the difference between clear cover and effective cover. Okay, this is very important, you should remember. Next, what are the different types of footing that should be provided in the structural member? Okay, so if you go for the structural member, the different types of footing should be provided in the construction. That is, first one is continuous wall footing, next one is isolated footing, combined footing, that is strip footing, strap footing, next one is a raft for footing, and next one is piled foundation. Okay, and you should know why, when these footings are to be preferred. Okay, when these footings are to be preferred. Okay, so I will show in the diagram. Okay, so if you'll go for this one, this is called wall footing. This one is called wall footing. Okay, and this one is called, second one is called isolated footing. Okay, what do you mean by isolated footing? Means for single column, if you want to provide a single footing, then it is called isolated footing. Again, in isolated footing, there are different types of footing. That is called simple spread footing or stepped footing, and different next one is that is sloped footing. Okay, depends on the, as a designer point of view, you can go for this one. If you want to achieve the economy, you can go for, though it depends on your requirement. Okay, usually if you go for this type of step footing, slope footing, there will be a problem in the shuttering. Okay, so directly, in order to avoid the complication, the shuttering, directly box like footing is to be done in the construction. Okay, this is as per your designer requirement, you can go for proceed for that case. Okay, next one is, first one is that is column footing, wall footing. Next one is that is isolated footing. Next one is combined footing. Next one is that is combined footing. When you go for combined footing, okay, usually what happens, if the columns are very nearer, say this is the plan of the building, say this is my plan. Okay, say if two columns are very nearer to each other, if two columns are very nearer to each other, if you provide a isolated footing, if you provide a single footing, these two footings are overlapping, That's why it is not possible to provide a single footing. At that time, what you have to do? You have to go with the combined footing. You have to go with the combined footing. Okay. Next one is that is strap footing. Strap footing means the two footings are connected by a beam. These two footings are connected by one beam, that is called strap footing. Usually what happens, sometimes the column is at the edge of the building. The column is at the edge of the building. At them it is not possible to provide the rectangular footing, means at that time you have to go for eccentric footing. So that at that point you have to go with the strap footing. Okay, next one is that is called strip footing. Strip footing is it is just like a wall footing only. Okay, for below the wall the footing is to be provided, that is called your strip footing. Okay, next one is that is raft foundation or foundation, or you can say raft footing. What do you mean by raft footing? If number of columns are more very near, okay, if number of columns are very nearer to each other, so instead of providing the individual footing, what we will provide? We will provide a common mat. Okay, we will provide a common mat, then that is called, that is mat foundation or raft foundation. Next one is pile foundation. What do you mean pile foundation? Pile foundation means if the SBC, if the safe bearing capacity of the soil is very less, at that time you have to go for which kind of foundation? We have to go for pile foundation. I already got an idea. What do you mean continuous wall footing? Below the wall the footing is to be provided, that is called continuous wall footing. Isolated means for single column the footing is to be provided, that is called isolated footing. Okay, in isolated footing are different types of slope footing, step footing. Okay, and combined footing, if two columns are very near to each other, we go for combined footing. String footing is similar to wall footing. Strap footing, that is two footings are connected with a strip beam, that is called strap footing. Raft means if number of columns are very near to each other, at that time you have to go for raft footing. And next one is file is if SBC of the soil is very low, at that time you have to go for pile foundation. Okay, we'll move for next question. Okay, what is the unit weight of concrete? Okay, what is the unit weight of concrete? Okay, you should know if it is plain concrete, if it is PCC, unit weight of concrete will be 24 kilonewton per meter cube. 24 kilonewton per meter cube. If it is RCC, how much you have to take? 25 kilonewton per meter cube. You should remember this one, it's very important. Okay, whenever if you solve the problems or in the design, if you're using software, you have to enter these values. Okay, so for plain concrete how much you have to take? You have to take 24 kilonewton per meter cube. For RCC reinforcement concrete you have to take 25 kilonewton per meter cube. Next, what is the unit weight of steel? Okay, unit weight of steel how much? That is 78.5 kilonewton per meter cube. This is the unit weight of steel. Okay, if you are to tell in kg, that is 7850, that is kg per meter cube. This is the unit weight of steel. Okay, next, what are the nominal concrete mix proportion for different grade? Okay, what are the mix proportion that is to be used for different grade of concrete? For M5 the mix proportion is 1:5:10. For M10 that is 1:3:6. For M15 1:2:4. For M20 1:1.5:3. You have to remember this one, is very important. Okay, whenever if you go for in the site, this is the mix proportion most probably used. M20 and M25 and M30, most probably M20 and M25. So for M20 mix proportion will be 1:1.5:3. For M25 it will be 1:1:2, and for M30 it will be 1:1:3. Okay, here what is indicates 1, 5, 10. Okay, the first word that will indicates, first is cement, second one is sand, and the third one is aggregate. Means that is cement is to fine aggregate is to coarse aggregate. Okay, this is the means if you take one bag of cement, say for the M20 grade. Okay, if you are taking one bag of cement, means you have to take 1.5 bag of fine aggregate, that is sand. Okay, and similarly that is 3 bag of coarse aggregate. This much a proportion you have to take, and you have to mix it, and you go for the concreting. Okay, next, Okay, how do you find the weight of steel bar used in the reinforcement? Okay, usually you should know how much weight of steel that should be required in the construction. Okay, so weight of bar in kg per meter, how will calculate? So what is the formula for that one? Is that is d square by 162. This is the formula you are supposed to use, d square by 162. Means you have it, how you have to calculate? Means say if I am using 12 mm bar, what I am using? Yeah, I am using 12 mm bar. So I want to calculate per meter how much weight is there. Per meter how much weight is there. So I use this formula. So that is 12 square divided by 162. 12 square by 162 means you are getting 0.89. Means what it show? Means 0.89, 0.89, that is 0.89 kg per meter. 0.89 kg per meter, per meter 12 mm bar is there, means per meter how much weight is there? 0.89 kg is there. Okay, so if you are using 12 meter length, means we have to multiply with 12, means that much of kg of steel, that is for that much of length bar. Okay, this is the thing you should know. The formula is very important. Okay, you should remember that is d square by 162. How much? That is d square by 162. Okay, we'll move for next question. Okay, uh, what is the difference between one-way slab and two-way slab? Okay, so it is very important. Okay, what do you mean by one-way slab? Okay, one-way slab and two-way slab. One-way slab means if the ratio, the longer span to shorter span is greater than 2, then it is called one-way slab. If it is equal to or less than 2, then it is called two-way slab. Okay, the ratio, that is longer span by shorter span, if it is greater than 2, then we'll say one-way slab. Okay, if the ratio ly by lx, okay, ly means that's longer span, shorter span, if it is less than or equal to 2, then we will say that is two-way slab. Then we'll say two-way slab. Okay, next, in one-way slab what happens? In one-way slab, the load is distributed along shorter direction only. The load is distributed along shorter side only. Okay, this is the one thing you have to remember. And in case of two-way slab, in case of two-way slab, the load is distributed along all the four sides. Load is distributed along all the four sides. Okay, and one more point you have to remember, if it is two-way slab, how the load distribution take place? How the load distribution it will take? Okay, in two-way slab, the load distribution, how it take place means, say for this beam, how the load distribution take place means the trapezoidal load that will transfer to this AB beam. Same thing if you go for the BC beam, how much load it will take means, for BC beam this triangular load will transfer to this beam, and according to you have to design this beam. Okay, this is the difference between one-way slab and two-way slab. One-way slab means that is greater than 2. If longest span, shortest span is greater than 2, that is one-way slab. If it is less than or equal to 2 means that is called two-way slab. Okay, I already got an idea about this one. Okay, next. Next, what do you mean by flat slab? Okay, flat slab means the slab which is supported on columns. The slab which is supported on columns means there is a beam free structure. Okay, there is no beam you will observe in the slab. Directly this slab is resting on column. This slab is directly resting on the column. Then that type of slab is called flat slab. Okay, if you want more clear height, usually if you want more clear height, you can prefer flat slab. Okay, aesthetically it will look good. It will look good also. Okay, if you are preparing for flat slab. Okay, we will move for next one. What is the height of each floor? Okay, if you construct any residential building, okay, what is the height of each floor? So usually the minimum height should be equal to 3 meter. It should be minimum height should be equal to 3 meter. Okay, as per National Building Code, the height of all the room should not be less than 2.75 meter. It should not be less than 2.75 meter measured from the surface of the floor to the lowest point of ceiling. This is the one thing you have to remember. Okay, so you have to remember the minimum height should be 3 meter. Okay, next. What is the length of rise and tread in staircase? Okay, if you're designing a staircase, you should know what is the minimum length of tread and what is the minimum length of rise. Okay, it will be rise will be 150 to rise will be 150 to 200 mm, and tread will be 250 to 300 mm. Okay, in the diagram I will show how what is rise, what do you mean by thread. Okay, if you see in this diagram, okay, this vertical part that is called rise, and this horizontal part will be called tread. Okay, this will be 150 to 200, and this and that the rise will be 150 to 200, and tread will be 250 to 300. Okay, in the diagram it is shown. Okay, we'll move for next question. If you want to tell in the inches, this will be riser will be 6 inches, and tread will be, that is, 10 inches. Okay, next, what is the slope of staircase? Okay, if you're going for a design, if you're going for a construction of a staircase, okay, as per IS 456, the slope of staircase should be between 25 to 40 degree. Okay, what is the angle? This should be 25 degree to 40 degree should be maintained. How much you have to maintain? 25 to 40 degree. Okay, we'll move for next one. Okay, what is the crank length in slab? What is crank length in slab? Okay, crank length means what? Okay, in the diagram I will show you. Just see it. Okay, so the crank length in the slab is, that is 0.42 times of d. 0.42 times of d. This is called crank length. This one is called crank length. Okay, how much it will be provided? That is 0.42 times of d. D is the depth of slab. D is the depth of slab. Okay, it is given here. That is called crank length. Next, what are the different types of slump? What are the different types of slump? Okay, so the different types of slumps means, first one is, that is called true slump. First one is, that is true slump. Second one is, that is shear, collapse, and zero. Okay, means what do you mean by true slump? What do you mean by collapse? Okay, just we'll see it. True slump means the concrete mass after the test when slump evenly all around without disintegration is called true slump. This is called true slump. Okay, means the concrete mass after the test when slumps evenly, it slumps evenly all around, then that is called true slump. Shear means what? Means one half of the concrete mass slides down. One half of the concrete mass slides down. It is called shear. Next one is collapse. When you remove the cone, that is slump cone, so means the concrete will be collapsed, means due to excess water. Okay, this is called collapse. Okay, next one is zero. Zero slump means it is very stiff concrete. If you remove the cone, there is no settlement, means there will not be any kind of drop in the height of that cone. Okay, concrete. Okay, so that is called zero slump. Okay, for normal, if you want to go for any concrete mix, the slump should be in the range of 20 to 90 for good workability. If you want to go for reinforcement for foundation, okay, for concreting, this much of the slump should be okay. If you go for columns, that should be in the range 20 to 100. Okay, for good workability. Next, okay, what is grouting? Okay, grout is a fluid from the concrete which is used to fill the voids. Okay, next, what is allowable moisture content in filed aggregate for the concrete mix? Okay, what is the minimum? What is the allowable? What is the allowable moisture contents means? That is, we will not allow more than 5% of moisture in the aggregate. Okay, you should remember, it's very important. Okay, we will not allow more than 5% of moisture in the aggregates. Next, what is bleeding? What do you mean by segregation? Okay, what do you mean segregation? Segregation means it is a separation of cement, sand, and aggregate. It is a separate. It is a segregation. Segregation means what is the meaning of segregation? It is a separation of cement, sand from aggregate. Okay, in the picture it is already shown. Okay, if this is the thing that will happen if its segregation happens. This is caused due to water cement ratio, and when the concrete is poured from about a height of 1.5 meter. Okay, this is called segregation. Okay, we'll move for next one. What is seepage? Slow percolation of water through a soil is called seepage. Slow percolation of water through a soil is called seepage. Next, what is the compressive strength of brick? What is the compressive strength of brick? Okay, for second class brick, that is 70 kg per centimeter square. Kg centimeter square. Okay, for first class brick, that will be 105 kg per centimeter square. Kg per centimeter square. For fire brick, it will be 125 kg per centimeter square. You have to remember, for second class brick it will be 70. For first class brick it will be 105 kg per centimeter square. Okay. Next, what is the okay, next one is, how do you check the quality of cement in the site? Okay, how will check the quality of cement in the site? Usually if you are working as a site engineer, the cement will come to the site, and if you want to check is this cement is good or not, by observing in the site itself without conducting any kind of test. Okay, how will check means, first, okay, one thing you have to remember. Okay, if you are using, you have to see the manufacture date. You have to see the manufacture date. Okay, means the cement you will be used before the 3 months of manufacture. Okay, means it should not be more than the manufacture date is more than 3 months if you are not supposed to use. Okay, if you want to store the cement, you should store up to 3 months only, or you can use that cement before 3 months only. Okay, then it will give the good quality cement. Okay, next one is color. Okay, by observing color also you can tell which type of which is it cement is good or not. Okay, color should be gray with light green shade. Color should be gray with light greenish shade, and it should be uniform. It should be uniform. Color gives an indication of excess of lime or clay. Okay, next, float test. Float test means what? A good cement won't float if you throw a cement in water. Okay, if what you have to do, in a bucket you have to take the water and throw some amount of cement in the that bucket. Okay, if it should not float. A good cement won't float if you throw in a cement in water. It should not float. It should be settled in the bottom. Okay, you should remember this one. Next one is, if next, when you put your hand in a cement bag, it should feel a cooling effect. Okay, between the finger you will feel the cooling effect. These are the 4 tests we can conduct in the site if you want to check what is the cement you purchase, is it good or not. Okay, next we'll move for next question. Okay, next, what is the initial and final setting of cement or cement concrete? What is the initial and final setting time of cement? That will be, for initial setting time of cement is, that is 30 minutes, and final setting time will be, that is 10 hours. Okay, next, what is bleeding in concrete? Okay, bleeding means it is separation of water. Bleeding is one of the segregation where the water comes out to the surface of the concrete. Okay, it will come to the surface. Okay, that is called bleeding. Next, what is the name of machine to check the compression test? Okay, usually compression test will be conducted on, that is universal testing machine, UTM. What you will say, that is UTM. Okay, you can test this one, compression testing machine also. This compression testing machine also you can conduct the test. Okay, next, when we go for pile foundation. Okay, already you know, when we prefer pile foundation, if say bearing capacity of the soil is very low, is as soil is very low, then we'll go for pile foundation. Okay, we say bearing capacity is less than 24 kilonewton per meter cube. If SBCF soil is, that is less than 24 kilonewton per meter cube, you should go for pile foundation. Okay, it's very important, you should remember this one. Okay, we'll move for next one. What are the steps involved in the concreting process. What are the different steps that should be involved in the concreting process? The steps are, first one is that is batching, mixing, transportation and placing. Next one is compacting. Okay, what do you mean batching? Batching means it is a measurement. It's a process of measurement of different material. Means if you are using cement, cement, you are using fine aggregate, you are using coarse aggregate, you have to measure the quantity, how much quantity is to be required. Okay, this is called batching. Okay, there are two types of batching. You can measure by, can go for volume batching, or you can go by weight batching. Okay, these are the two different methods you can follow for that case. Next one is mixing. In order to create a good concrete, proper mixing should be done. Proper mixing means what? Means proper mixing means you should first go for dry mixing. First what you have to do, you have to put first we have to put coarse aggregate. After that you have to put sand, and you thoroughly you have to mix. After that when you have to mix cement. Okay, after that you have to mix cement. It should show uniform color. Okay, after that you go for wet mixing. Okay, this is the procedure. Then only you will get a good concrete. Next one is that is transportation and placing. Always try to mix the concrete near to the site, or near the where you want to go for concreting. Okay, that is once the concrete mixture is created, must be transported to its final location. The concrete is placed from works and should be always to be dropped in the final location as closely as possible. Next one is last one is that is compaction. Last one is what? That is compaction. Okay, means compaction, it is very important. Okay, simply for putting the concrete, if you are not going for compaction, the strength of the concrete what you are expecting, it will not achieve. Okay, so if you are not going for compaction, the 30% of strength will be reduced. Okay, the proper compaction is to be required. Compaction is to be done by hand by, you can go for manual method, or you can use some vibrators for the compaction. Okay, if you want to get the desired strength, you should go for proper compaction of the concrete. Okay, next. Okay, describe briefly the various methods of concreting. Describe briefly the various methods of concreting. Okay, the describe briefly the various methods of concrete curing. Okay, usually you have to go, if you want to get the desired strength, okay, you should go for that is curing. Okay, so what are the different types of curing? That is spraying of water on the walls and columns can be cured by sprinkling a water. Okay, next, wet covering of surface can be cured by using the surface with wet gunny bags. Okay, next, that is pounding. The horizontal surfaces inclined, including the slab and floors, can be cured by the stagnating the water. Okay, means by pounding. Okay, by pounding you can cure the, that is slab. Okay, horizontal floors. Steam curing. Okay, prefabricated concrete units, steam can be cured by passing it over the unit that under the closed chambers. Okay, and next one is by the application of curing compounds. Compounds having calcium chloride can be applied on curing surface. This keeps the surface wet for very long time. Okay, these are different types of curing. Okay, one more thing you have to remember. Usually the curing is to be done for 28 days. Why? What is the reason? Why have to go for 28 days of curing? Okay, whenever you'll see, they will say 28 days of curing is to be done for the concrete. Why? The reason behind that one is complete hydration of cement concrete that will be happen for 28 days. Okay, means what happens means, say if you cure for 28 days, means 99.99% of strength is achieved by the concrete. Say means if M20 grade is there, M20 means what? Means 20 Newton per mm square. This much of strength will be achieved after 28 days of curing. After 28 days of curing means the concrete is, it should show this much of strength. Okay, if you are not doing 28 days of curing, you will not achieve this much of strength, 20 Newton per mm square. That's why you have to go for 28 days of curing. Okay, complete hydration will happen and 99% of strength will be achieved after 28 days of curing. Okay, this is the one thing you have to remember. Next, that is thickness of plastering. Okay, external plaster recommended thickness of cement plaster is 6 mm. The cement plaster will be 6 mm for ceiling and concrete plastering. Next one is for 12 mm for internal wall plastering and plain surface brick. Okay, for 12 mm is for internal wall plastering and plain surface of brick. Next, 15 to 20 mm, 15 to 20 mm for external wall plastering rough surface of brick. Okay, this is the question we have to remember. Okay, next, this question is asked when I gone for the design engineering interview as a structural engineer. I went for the interview. This question has been asked: what is the thickness, internal wall thickness, how much you will provide, and what is the external wall thickness you should provide. That's why you don't expect which type of question that will come in the interviews. Okay, you were preparing for only softwares. They are asking some other things. Okay, that's why you should perfect for all the cases. Okay, next, what are the different tests that will be conducted on cement? Okay, so if you are using for the cement, what are the laboratory tests that should be conducted? Okay, those tests are, that is fineness test, consistency test, setting time test, that is strength test, soundness test, heat of hydration test, tensile strength test, and chemical composition test. These are the different tests that should be conducted in the laboratory. Okay, fineness test, that is by CU test or by air permeability test. Okay, next, consistency test is to be conducted by wicket apparatus. Okay, that is initial setting time and final setting time, that is 30 minutes, and final setting time will be 10 hours. Next, that is strength test, soundness test of cement. It is to be done by leach atelier apparatus to detect the presence of uncombined lime and magnesium in cement. Okay, next, that is heat of hydration test. Okay, during the hydration of cement, heat is produced due to chemical reactions. Okay, this is the one thing you have to remember. Next, this test is carried out using a calorimetry adopting the principle of determining the heat degree. Okay, next one is tensile strength test of cement. Test is carried out using cement mortar. Okay, next, chemical composition test. Okay, different tests will be conducted to determine the amount of various constituent of cement. The requirements are based on IS 269 1999 as follows: the ratio of the percentage of alumina to that of iron oxide should not be less than 0.06. Okay, and lime saturation factor, the ratio of the percentage to that alumina, iron oxide, and the silica should not be less than 0.66 and not greater than 1.02. The total loss on ignition should not be greater than 4%. Okay, total sulfur content should not be greater than 2.75%. Weight of insoluble residue should not be greater than 1.5%. Weight of magnesia should not be greater than 5%. Okay, this is the chemical composition. It should be as per requirement. You should follow these things. Okay, next one. Okay, it's very important. That is uh, define lap length. What do you mean lap length? The amount of overlapping. Okay, the amount of overlapping between two bars is called lap length. It is shown in the diagram. The lapping is usually done where minimum bending stress is encountered. The generally lap length is 50D, which means 50 times the bar diameter. Bar diameter if the both bars of same diameter. Okay, you should remember. This is the lap length. Okay, lap length. You usually this is the type of, we will proceed for that case. Okay, we will move for next one. Okay, if you see in this diagram, okay, usually in the diagram here given here cross marks, here you is going to right mark. What is the reason behind that one? Why the lapping is to be done like that only? Why it is not like that? Okay, just one thing you have to remember. Say if, say this is the column. Okay, say these are the bars. This is the bars. Okay, if you want to do the lapping, say if I done the lapping like that. Okay, if I done the lapping like that. Okay, if I done the lapping like that means what happens? Your lapping is to be done at same point. means you are creating a weak zone. Okay, all the joint lapping is done at same point, means you are creating the weak zone in the structure. Okay, that will make a problem. That's why you are not supposed to do the such a kind of lapping. It should be done, you can do here, two you can do here, next two you can do here. This is the way you have to go for lapping, otherwise it will become a weak zone, may structure may collapse. Okay, you should maintain the proper detailing. Okay, means proper connection should be done. Okay, so this is the diagram it is shown, that's why it is cross mark has been given here, here it is right mark has been given. Okay, next we will move for next one. That is, what do you mean by development length? What do you mean by development length? Okay, development length can be defined as the amount of reinforcement length needed to embedded or projected into the column to establish a desired strength. To establish a desired strength between the concrete and steel. Between the concrete and steel. Okay, this is the one thing you have to remember. This is the definition for development. This is also called as an anchorage length in case of axial tension or axial compression, and development length in case of flexural tension or flexural compression. Okay, means what do you mean development length? Means the minimum length that should be embedded in the concrete to achieve the desired strength of, in order to achieve the desired strength. Okay, in the diagram I will show. So this is your LD. This is your LD. Okay, in order to, so this is the LD. Okay, I will give the, I will show the formula for to calculate the LD. Okay, the formula for LD calculation will be, that is LD is equal to, that is 5 sigma s divided by 4 times of tau BD. 4 times of tau BD. What do you mean by 5? That is 5 means that is nominal diameter of the bar. Means say if you are using 8 mm bar, or if you are using 10 mm, if you are using 12 mm. Okay, that is the diameter of that bar. Sigma s. Sigma s is the stress in the bar at the section. Next, tau BD. This tau BD means that is design bound shear stress. Design bound stress. Design bound stress. Okay, you will get it in IS 456 in the clause, that is 26.2.1.1. Okay, in the here you will get this value, design bound stress. Okay, for M20, M20 how much is there, for M30 how much is there. Okay, M20 1.2 something there. By seeing IS code book you have to prefer this one. This is the length of development, at how we have to calculate by using this formula. Next, what is the difference between lap length and development? What is the difference between lap length and development length? Lap length can be defined as the length that is to be needed for overlapping two steel bars, and so they act as a single bar. This is the definition for lap length. For body mean development length is defined as the length of the steel reinforcement from one element to another element needed to transfer the stresses. Okay, already we discussed about this one. Okay, this is the diagram is given here. This is your LD. Okay, next. Okay, some of the important points should be remembered if you are a civil engineer. Okay, just we will discuss one by one. Minimum thickness of the slab, how much you will provide, that is 125 mm. Okay, next, in case of column, what is the minimum percentage of steel that should be provided? That is 0.8% of BD. How much you will provide? That is 0.8% of B into D. Okay, 0.8% of B into D. What do you mean by B into D? Say your column dimension is say 230 by 600. 230 by 600 means we are, in case of B we have to put 230, in case of D we can put 600. Okay, accordingly we can go calculate the percentage of steel. Next is maximum percentage of steel in the column, that is 6% of BD. 6% of B. B is the width and D is the depth of the column. Next, water absorption should not be greater than 15%. It should not be greater than 15%. Next, in case of bricks. Okay, next, dimension tolerance for cube will be plus or minus 2 mm. Dimension tolerance should not be more than plus or minus 2 mm. Okay, next, Lapping is not allowed for the bar having diameter more than 36 mm. You have to remember this one. You should not do the lapping if the bar diameter is more than 36 mm. Okay. Next one is chair spacing. Maximum is 1 meter or one number per meter square. Chair means in order to support the horizontal bar, we'll provide the chair like that. Okay. You have to provide the reinforcement like that in this direction. Okay. So the chairs are, we should do spacing is 1 meter or one number per meter square. For dowel rods, minimum 12 mm diameter should be used. Minimum 12 mm diameter should be used. Okay. Chairs minimum of 12 mm diameter bars should be used. Okay. For dowel also 12, for chairs also 12 mm. Longitudinal reinforcement. Okay. Just now is discussed. Okay. Minimum number of bars in case of rectangular column. So this is the column. How minimum number of bars how will provide? Okay. So if it is rectangle, minimum number of bars how much? Okay. So minimum number of bars should be 4. Minimum should be 4 in case of rectangular. Okay, same thing in case of circular. In case of circular, what is the minimum number of bars will provide? The minimum number of bars in case of circular will be how much? That will be 6. Minimum number of bars should be provided in circular column will be 6. Okay, next. Okay. In steel reinforcement, binding wire required is, in steel reinforcement, that is binding wire required is 8 kg per metric ton. How much will required? 8 kg per metric ton. 8 kg per metric ton. Okay, next. In soil filling, as per IS code, 3 samples should be taken for core cutting test for every 100 meter square. You have to remember this one. Okay, for soil filling, as per IS code, 3 samples should be taken for core cutting test for every 100 meter square. Next, compressed strength of brick is 3.5 Newton per mm square. Maximum free fall of concrete is allowed from height of 1.5 meter. Maximum height should not throw the concrete from more than 1.5 meter. Maximum is 3.5 meter. If soil filling as per IS code, for every 100 square meter cube sample, core short cutting should be taken. Okay, just now we discuss. Next, electrical conduits shall not run through column. Why? Okay, usually what happens, column is the major structural member. Okay, you should not allow to make this column should be weak. Okay, if you provide any kind of hole in the column, that will reduce the strength of column. That's why you should not pass any electrical conduits, shall not run from the column. Earthwork excavation for basement above 3 meters should be stepped from. Okay, next, any backfilling shall be compacted 90% of dry density at the optimum moisture content and in a layer not more than 200 mm for filling above the structure and 300 mm for no structure. Okay, next. Okay. A set of cube tests shall be carried out for each 30 meter cube each level of costing or each batch of cement. You have to remember. Okay, always if you have to go for concreting, okay, you have to check the strength of that concrete. That's why he is telling a set of cube test shall be carried out for each 30 meter cube of concrete or each level of costing or each batch of cement. Next, water cement ratio for different grade of concrete. The different grade shall not exceed 0.45 for M20 and 0.50 for M10 and M15. Okay, go for next one. For concrete grade M20 and above, approved admixture shall be used as per mix design requirement. Okay, next. Okay, cement shall be stored in a dry places on a raised platform about 200 mm above the floor level. You have to remember 200 mm above the floor level and 300 mm from wall. Okay, from above floor level how much? That is 200 mm and from the wall that should be 300 mm away from the wall. bag is stacked not more than 10 bags. Okay, and such a manner that it is adequately protected from the moisture and contamination. And from the date of manufacture, how many months you can store the cement bag? Only 3 months. Okay, after the manufacture date, means before 3 months, you can use that cement if you want to get the good strength of that cement, good quality cement. If you want, you can use before 3 months. Okay, if you want to use after, you have to check the property of that one. Okay, next, that is lap length for M20 concrete. Okay, already we discussed what do you mean by lap length. Okay, for lap length, so if it is column, it will be 45D. D means diameter of the bar. 45D for column. For beams, it will be 60D. On slab, it will be 60D. Okay, for column 45, for beams and slab, it will be 60D. D is the diameter of the bar. Okay, these are the very important points you should be remembered. Okay, if you like my video lecture, so I request you to like, subscribe and share with your friends. I will try to make more videos on this one, that is it related to civil engineer. So thank you one and all.